welcome back. All right, so now in this part of the series for this Griffin tape deck from 1962, I think, well, we've already done the voltage checks and stuff like that and determined that this thing is in major need of recapping. So at this point, I just want to do sort of a circuit trace through the RP unit and identify things that are going to, possibly throw me a curveball. Well, curveballs notwithstanding, this whole episode took a completely different detour. You'll hear me mention capacitor interruptus. Well, it's a thing. What I'm sort of curious about is, in looking at this chassis, and of course everything in here is point-to-point soldering, which is going to make it real easy to work on, because what I like to do is to simply trim the capacitor to be replaced right at the capacitor, leaving as much lead still soldered to the terminal strips and so forth. So I have a little bit of slack to work with, particularly because a lot of these capacitors in situations like this are going to end up being smaller than the capacitors that they are replacing, because technology has improved. They've managed to trim things down a little bit. In this particular scenario, things are kind of layered. You got a capacitor, and then you got resistors on top of that are going perpendicular, and then you may have another capacitor on top of that. You just want to give it a real good once over, okay? Maybe even a twice over. Something like this, you don't want to miss anything. Lo and behold, I want to point your attention to this resistor right here. That's discolored. I mean, it's got a very dark, toasty looking ring that's going around it right there. That means that puppy got hot, and it's rated with enough headroom that should not be happening, which means that something is drawing excessive current through there, and wouldn't surprise me if it's a capacitor. Again, resistors, typically, they really don't want to drift off of their value without some excessive amount of evidence, like lots of smoke. I think the thing that really helped save this from excessive damage is the fact that when we powered it up, we raised the voltage on the bench supply very slowly, so it didn't, hurt it so much. But let's go ahead and just check that resistor. Let's find out what we're dealing with here. 480. All right, so it's climbing. So there's obviously some capacitor involved with that. Now, one way of doing that is basically lift one leg of that resistor up and measure it outside the circuit. It's always a good idea to lift it out of the circuit, but we're on fact finding right now. So coming off of this resistor, what's going into this resistor is this brown wire. All right, so coming off of the full wave rectifier, which is a 6X4, okay, that's coming off and going to the filter cap over here, which is going to be a 40 mic at 400 volts, I believe. Okay, so that's the first filter cap, and then it comes off. That filter cap goes through the chassis to a wire wound resistor on the other side, and then doubles back, okay, to this capacitor in the same can, which creates what's called a pi filter. So coming off of the vacuum tube, you've got a capacitor with a resistor, capacitor to ground. Okay, there's ground right there. Capacitor, resistor, capacitor. So it basically creates the appearance of the Greek letter pi. What I'm noticing is that brown wire I'm talking about going to this resistor, and that's the only thing it goes to, which means this is getting practically the full brunt of the voltage coming off of the rectifier tube. And what ends up happening is that it's coming off there, going to that resistor, and coming off of that resistor are two capacitors. So the current through this resistor is going through those capacitors, and from those capacitors, it's going to this oscillator circuit, which is for the AC erase and AC bias for the record head. So you got the erase current, you got bias current, and that's what's going on here. With paper oil capacitors, you just assume they're bad and change them, okay? But I think what's happening here is that there's too much current going through here, which probably means that these capacitors are passing too much DC. These two capacitors here, just by the way, are going to be your coupling caps that take the recorded audio portion and combine it to the AC bias for the record head. So these are coupling that, okay. A doorbell and Capacitor Interruptus. Excuse me. All right. I have no idea what the hell this is. Well, it's packed incredibly well. What the hell? Oh, wait a minute. Oh my God. Holy shit. This is an RP unit identical to the one that we're about to work on. Porn! Ooh, I bet it's even got pictures. You know what this means? Oh, it's an extra pinch roller. I wonder if this has got the conversion kit. And the reason I say that is because this looks like, right there, Denon. And it's all in Japanese. But even then, even with Japanese, okay? Kilogram is still a kilogram. May not know what this says, but it's 70 kc. Okay, that's going to be the bias frequency. So what happens is kilocycles and kilograms and all that kind of stuff, numbers are going to be the same numbers. Numbers are numbers are numbers, all right? May not know what the words are, but we can figure it out, okay? Heck, nowadays there's probably an app for my phone. Okay, this is no doubt the owner's manual because it's got the pretty picture on it. See, like that. Transport. Transport. Oh man. You don't suppose. Man, you guys see this. I mean, this is incredible. I mean, with wrapping all the way around, bubble wrap and everything else. Wow. Check this out. And this is in such great shape. Now, he said nothing to me about this. He said, not word one. There were two boxes. A big one and this little one. Hang on a second. And that's Denon. That's the one that was manufactured and released specifically for the market in Japan. Okay, again, in the early 1960s. Okay, so this is instructions. This says it's instructions. Maintenance. I like to go to the end of the book and see how it ends. Schematics. Anybody? Please, 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 please. Schematics, perhaps? Okay. All kinds of mechanical parts are listed. Again, mechanical parts. I mean, if there's schematics in here, that could very well help troubleshoot so much of this. Yeah, decrease, increase, brake tensions, solenoid travel adjustments. What is this? Okay, it's talking about switching from 50 cycles to 60 cycles and changing the capstan capacitor, 1.5 mic to 0.5 mic. Okay, well, I'm not seeing a schematic yet. And even if there isn't one, we can get by. We can figure out where all of the gazintas and gazautas are. And this pinch roller, a 50 cycle electrical system, the capstan would be spinning at a particular speed, but it would be slower than in America, which is 60 cycles per second. Our electrical system, 60 hertz, okay? And if you've ever grabbed a hold of a naked extension cord, you know how much it hurts. What is in here? Denon tubes. Ta-da! Denon tubes. They're all individually wrapped here. Look at this. Holy cow. Hang on. Seriously? Big mystery. Well, we're going to try to solve that mystery. Some of you may recognize us. I am curious. I mean, what could possibly be on here? I mean, come on.
Good morning, Mr. Phelps. The package you've received contains a vintage high-fidelity stereo tape deck, originally branded as Denon, manufactured in Japan in the early 1960s. The production of this device mirrors the same techniques and components as the Griffin tape deck that now graces your laboratory workbench. Your mission, should you choose to accept it, is to bring either or both of them to operational fruition. In so doing, identify dissimilarities, if any, and all while bringing definitive 6R principles to bear. As always, if you or the 6R budget are in any way compromised in your undertaking, the Secretary will disavow your attempts, and you will be responsible for costs associated with return shipping. This tape will self-destruct in 5 seconds.
Oh, shit!